Chapter 6, Test Corrections for Accelerated Geometry. Alright, question number 1. Determine the best name for the given quadrilateral. This is the quadrilateral. By the notation, we can tell that these two lines are parallel and that these two lines are parallel. And all the sides are congruent. Alright, the correct answer would be this quadrilateral is a rhombus, because we don't know if the angles are right. Thus, rhombus. Okay, problem number 2. State as true or false. A parallelogram can be a kite. This is false. A kite has two adjacent congruent sides, and a parallelogram has two opposite congruent sides. Alright? A parallelogram has opposite congruent angles, and a kite only has two congruent angles that are opposite. Right there. And then the diagonals in a kite are perpendicular, and in a parallelogram they are not perpendicular. They might be, but they're usually not, I guess. I mean, they cannot be perpendicular. Yeah, that's what I'm trying to say. Anyway, yeah, parallelogram cannot be a kite. False. So here is 24. I didn't want to write this on the board because I didn't think by the time I had wrote it all, you would probably not be able to read it. So here is the paper. I missed D and E. Okay, so in this proof, we know that, or we're trying to prove that ABCD is a parallelogram, and we know that A and C are congruent, and that B and D are congruent. So, up to D, I knew that AB and AD are supplementary angles. So, because I know that they're supplementary angles, the converse of, because they're supplementary angles, I can use the converse of the same side interior angles theorem to figure out that BA and CD are parallel and BC and AD are parallel. And because I know that those four lines are parallel, I know that ABCD is a parallelogram, because the definition of a parallelogram is a quadrilateral with two pairs of opposite parallel sides. Hello again. I missed number 26. Alright? And 26. Find the value of the variables and show your work. So, we are given this shape right here. This diagonal is labeled 2x minus 1 and 3y plus 5. These parts are congruent, so they're equal to each other. And then BD, this line, is equal to 4x minus y plus 1. Now we'll get to that later. First off, we're going to find it. What do we find? Find x. Alright, so we're going to find x. To find x, you take 2x minus 1, equal that to 3y plus 5. Alright, so I'm going to do that. Alright, that. And then, plus the 1 over here. So add 1 to both sides to make this 2x equals 3y plus 6. Right there. 2x equals 3y plus 6. Alright, and then just divide both sides by 2. Alright, I can't really write sideways that well. But, yeah, so divide each side by 2, and you get x equals 1.5y plus 3. Okay. So we have x. We know x equals that. Now, we take x and we substitute it into 4x minus y plus 1, or wait, no. We take 4x minus 1 plus, or 4x minus y plus 1, put that into equation with the other lengths. 4x minus y. Alright, so we put this and these two added together into an equation, and we get 4x minus y plus 1 equals 2x minus 1 plus 3y plus 5. Alright, now we substitute in x for all the x's in this so that we can solve for y. I'm gonna put what I got after I distributed out the numbers. Okay, so I substituted x in for this x, and I got, well, 4 and then in parentheses 1.5y plus 3 and 2 parentheses 1.5y plus 3. So then I just distributed those out, and I got 6y plus 12 minus y plus 1 equals 3y plus 6 minus 1 plus 3y plus 5. I ran out of space here, so I just put it right there. Alright, now I'm going to simplify that and put all the like terms together. So that comes out to... Alright, that comes out to 5y plus 13 equals 6y plus 10. So, after I get that, I isolate the variable by subtracting 13 from this side and putting it over here, or subtracting 13 from both sides to get it over here, so that I get -3, and then subtracting 6y from this side and the other side and the side to get -y. Yeah. So then -y equals -3. And then multiply both sides by -1 to get y equals 3. Okay, so we know y equals 3. Now, you can put y back into a different equations to get what x equals. Okay. So, I'm going to put y into 2x minus 1 equals 3y plus 5. Alright, so I put y equals 3, so I put that 3 into 2x minus 1 equals 3y plus 5, which gets me 2x minus 1 equals 9 plus 5. Alright, so I get 2x minus 1 equals 9 plus 5. So, add up the like terms and then isolate the variable. You get 2x equals, well, alright, add 1 to both sides to get the 1 over there. Hold on. Blah, blah, blah. So that's 10, so that's 15. Alright, so, yeah, you add a 1 to both sides so that isolate the variable, and then you add up the like terms to get 15. So it's 2x equals 15, divided by 2. Divided by 2 to get to get x equals 7.5. Alright, so final answers. The values of the variables x equals 7.5 and y equals 3. Hello again. I missed number 27. Okay, so complete the proof, number 27. We are presented with this shape. We know it is a parallelogram because that is given. And so AB is congruent, or not congruent, AB and CD are parallel, and then AD and BC are also parallel. Okay, so I marked that on this square. No. Parallelogram. It's not a square, it's a parallelogram. So, given ABCD is a parallelogram, put that down right here because we were given that. Okay, we're trying to prove that AB is congruent to CD and then BC is congruent to DA. We know it's a parallelogram, so these lines are parallel. Alright, since these lines are parallel, we know that angle 1 and angle 4 are congruent because of the alternate interior angles theorem. Alright, yeah, so angle 1 and angle 4 are congruent because of the alternate interior angle theorem. Now, we also know that angle 2 and angle 3 are congruent also due to the alternate interior angle theorem. So, write that same thing to angle 3. Alright, angle 2 congruent to angle 3 because this means the same as this alternate interior angles theorem. Alright, so next up, we know that AC is equal to AC is congruent to AC because AC is AC, so the reflection property. We know segment AC is congruent to AC because of the reflection property. Alright, so segment AC is congruent to segment AC because of the reflexive property of equality. Alright, so now, since we know that these two angles are congruent and these two angles are congruent, and also this segment is congruent, we can prove that these two triangles are congruent by angle, side, angle. Because angle, side, angle, and angle, side, angle. So, so triangle ABC is congruent to triangle ACD because of ASA, angle, side, angle. Alright, so triangle ABC congruent to triangle CDA by ASA, angle, side, angle. So, since we know that these two triangles are congruent, by CPCTC, we know that AB and CD are congruent, and AD and BC are congruent. Alright, so AB is congruent to CD, and BC is congruent to DA by CPCTC. Thanks for watching my test corrections.